everyone. I see everybody coming in, so thanks so much for being here today. All right, well, we'll go ahead and kick things off. Thank you, everyone, for joining part one of the two-part webcast series we have with the Broadcom technical marketing team. I know many of you might have joined us last week at the VMUG virtual event, but if not, and this is your first time joining a VMUG event, thank you. We're excited and happy to have you here. If you have any questions throughout this webcast, you can use the Q&A feature, which would be preferred for asking questions. And then, of course, you can also use the chat if you have comments or want to chat with other folks. So thank you again for being here. We're excited to have you as part of the VMUG community. Please know that today's webcast is being recorded, so you will get access to this after, and then this webcast and all future webcasts can be found on vmug.com. So thanks again for being here. And with that, team, I'm going to hand it over to you. Thanks again for being here, and we can go ahead and get started.
All right, thank you, and welcome everyone. Thanks for joining us. Today we got, as you mentioned, members of the Broadcom technical marketing team, and we're going to be just doing a quick overview of what's new in VMware Cloud Foundation 9.0. We have a lot of content and a short window to present this in, so we're going to just jump right in. And I'll be passing off to others who will present various sections based on their areas of expertise. Headed out the gate, just want to kind of set the stage on how we've been looking at the private cloud in Broadcom. This is a pretty significant release for us. This is our first major release since the Broadcom acquisition. And it's an opportunity for us to show you what Broadcom has been working on and our efforts toward making the private cloud easy and to really deliver on that vision that our CEO presented at VM Explorer last year. And the way we look at it is we look at three pillars. We have modernizing the infrastructure, delivering this cloud operating model, and then, of course, providing something that is secure and protected. And today we're going to be focusing primarily on that first bucket, that modernized bucket. I'll be talking about getting started with the Cloud Foundation. We have a new component called the VCF installer and how we can use that to stand up your new Cloud Foundation instance, both on new infrastructure as well as how you can bring those existing vSphere environments that are in your data center today and convert them into a VCF private cloud. We'll be then get into some of the new features and capabilities available with vSphere 9, and then I'll be handing it off and we'll be hearing about some of the storage capabilities around vSAN and some improvements around stretch clustering, and then we'll get into VPCs and software-defined networking, and then we'll wrap it up with a quick discussion about fleet management and what this fleet management entails with VCF Operations and VCF 9. So a lot of content, a lot of good content here, and we'll just go ahead and jump in. So as I mentioned, we do have a new component. This is called the VMware Cloud Foundation Installer. So if you're familiar with older versions of Cloud Foundation, you'll remember we had something called the Cloud Builder. This is a replacement for the Cloud Builder. It's a new installer. This installer, it's called the VCF installer, but it's the same installer to deploy both VCF and VVF. So if you're running a VVF, vSphere Foundation, you use the same installer. And it does do the full stack deployment. So it will deploy everything to include standing up your vCenter servers, configuring your clusters, setting up your VDSs, deploying NSX, configuring your vSAN data stores, deploying operations, deploying automation. It's all a full, all-encompassing installer that will deploy the full stack. A couple of things that stand out about the VCF installer is particularly if you're familiar with the older Cloud Builder, is the VCF installer. It is distributed as an OVA, and it's about 2 gig in size. This is significantly smaller than the Cloud Builder appliance, and that's because it is we no longer ship the binaries with the installer. Once you deploy the installer, one of the first things you'll need to do is log into the installer to download the binaries. And another thing to kind of be aware of that creates a little bit of confusion, especially now that we're GA and people are going out to support.broadcom.com and they're downloading this, is they're noticing that the VCF installer is also available as part of the same appliance that is called the SDDC Manager. So yes, the SDDC Manager and the VCF installer are shipped together, part of the same OVA. When you first deploy the appliance, it deploys in what we call VCF installer mode. And then depending on your configuration and how you install it, it will either retain that identity and deploy a second instance as the SDDC manager, or it will reconfigure itself as the SDDC manager. So just be aware that it is the same appliance. In terms of once you deploy it, it's got a very simple UI. It deploys very easily, simple UI. As I mentioned, the first thing you need to do is download those binaries. So you'll log in and you'll set up a depot. We do have a choice of an online depot as well as an offline depot. So if you're a disconnected site, you don't allow your SDDC manager to or your VMs to have direct access out to the internet, then you can set up a local web server and you can host the binaries there and use that. And that's what the offline depot is. So you have the choice. You can go in and just connect directly using your software token and pull the binaries down, or you can set up a local web server where you host the binaries and pull them from there. There's also a new vSphere download tool, or VCF download tool, the VDT we call it. It's a command line interface that you can also use to download the binaries as well. So there's 3 ways you can get the binaries into your VCF installer. Once you have those binaries in, you can deploy it, and there is a choice of a wizard-driven deployment as well as a JSON spec. So if you want to go through the wizard-driven, where it will prompt you for all the inputs required, ask you for all the IP addressing, all the subnetting, and all the host names, you can just provide those inputs, follow the wizard. If you've done this several times and you want to automate it, you can also use a JSON spec where you basically go in and just update the spec and pass the spec in using API. So, and that's pretty much it. As far as the installer, like I say, it's pretty simple in terms of the user interface and pretty easy to get started with it. When you do the VCF deployment, you will be asked to choose your VCF topology. And there will be a new term in there we call VCF fleet. This may be a new term that you're hearing for the first time. So what exactly is a VCF fleet? Well, with VCF 9, we now include both VCF operations and VCF automation as components that are part of every VCF deployment. And those components, the operations and automation, if you don't have VCF in your environment, you'll need to stand those up. And you can stand those up by either taking an existing operations or automation instance and converting it into your VCF management domain, or you can deploy a new instance. If you are using operations and automation, you can continue to use those, and you can just bring those existing appliances in. If you're not using them, you will need to deploy them as part of your VCF deployment. And in addition, the operations and the automation components, they are components that you can have multiple VCF environments registered with them. So if you have an existing VCF instance with an existing operations and an existing automation, and you're deploying another VCF environment, you can just register it with that existing operations and automation. And so because the operations and automation can be shared across many VCF environments, those are what we refer to as fleet level components. So we kind of envision your private cloud as being comprised of a fleet with a centralized instance of operations and automation. And then underneath that fleet, you have your VCF instances that are registered with those fleet level components. So I can have one or more VCF instances registered with ops and automation. And so when you're deploying, well, basically this question about your topology, and if you're new or existing, it's basically asking you, are you deploying a new instance of operations and automation, or are you going to be joining an existing instance? And I already talked about those components, how they're new and they're now required. So let me see. And so in addition to the topology, I'm going to skip a bullet here and go down here to appliance model. Since we're talking about topology and we're talking about deployment, we also have this notion of a simple deployment versus a highly available deployment. Essentially what this is this is an effort we've done to kind of help make it so you can deploy VCF with a smaller footprint. So in the past, when you deployed VCF, and we would deploy things like the NSX manager or VCF operations or VCF automation, these components would all get deployed as multi-node clusters. So we have high availability built into these different components, and we would deploy them as a highly available cluster comprised of many different appliances, and then internally they could provide a level of resiliency that goes above and beyond what you get with vSphere HA. And so with VCF 9, we've relaxed some of those requirements, when you deploy in the simple mode, we allow you to deploy NSX Manager as a single appliance, the VCF Operations as a single appliance, the VCF Automation as a single appliance. And then, so you can start with a small footprint, and that works great for edge use cases, for remote sites, or for just labs and POCs. We have this simple deployment model. And for that simple deployment model, we're not devoid of high availability. We do have vSphere HA, we do have DRS, we do have vMotion. We do have tools there to help you with downtime avoidance as well as outage protection and failover should you have an outage. But it's just not as resilient and also the other thing to keep in mind is in addition to high availability, this also factors into performance and how you scale. So obviously you're not going to be able to scale as big and as large with a single node instance of VCF operations as you would with, say, a 3-node instance of VCF operations. So the simple and the high availability mode applies to both how we deploy and scale. So we can start small with that small footprint with leveraging vSphere HA for availability. And then as we grow or we get into these larger environments, we can also do the highly available model where we can deploy with built-in high availability, as well as we can also add in additional capabilities to scale. And so that's kind of an overview. Now, this last bullet here I'll talk about on this slide is deploy new or existing components. So one of the things we do with the VCF installer is we make it very easy for you to take those existing workloads running in your data center and to deploy them and to bring them into your VCF private cloud. So you can take an existing vCenter instance, an existing VCF operations instance, as well as an existing VCF automation instance, and bring that into your private cloud. So if you're familiar with VCF 5.2, we introduced a VCF import. It was a command line tool. Well, that command line tool is now built into the VCF installer. It's a part of the UI, so you no longer need that separate tool. But it's also, this has a key benefit because you no longer have to start with new servers. You can take those existing environments and bring those in. Okay, so that's the VCF installer. Now, another thing you'll notice as we go forward, we have an increased use of VCF operations in the new VMware Cloud Foundation 9.0. And a lot of the functionality that has traditionally been part of the SDDC manager is now available directly in VCF operations, as well as a lot of the functionality that was traditionally available in the SDDC manager is also available in the vSphere client. One example here is the ability to create a new workload domain as well as import a vCenter and create a workload domain from an imported vCenter. These are now part of VCF operations you see here in the UI. And so we basically have, in addition to this ability to import the vCenter, we've also moved that into VCF operations. Note when you are bringing an existing environment in, we can bring it in if it's running vSphere 8.0 update 1 or higher, as well as NSX. I believe this is a typo on my slide. Dimitri pointed that out, and I forgot to update it for this presentation. But I believe we can bring in NSX 4.1 and higher. One note here, because this question usually comes up about this time, is if you do bring an existing environment in, NSX will be deployed if it's not already in there. So you do need to deploy NSX. However, that's not to say that you have to start using NSX. You can deploy NSX, but you can keep your DVPGs and your VLAN-backed networks. We don't require any changes to get started with Cloud Foundation. Along with VCF operations, we also have some functionality that goes into the vSphere client. So here you'll see just a quick list where we can commission hosts, we can create and manage our pools, we can add clusters, we can add hosted clusters. Again, functionality that was previously available in Cloud Foundation via the SDDC Manager. They're still provided by the SDDC Manager, but to access these now, you go through the vSphere client. So we've done a lot of work to kind of consolidate our UIs and to reduce the number of UIs and provide less bouncing around. So you'll see when you deploy VCF 9 and get started with it, you'll see these changes. Okay, so that's just a quick introduction. So the VCF installer, a new way to get started, a new way to deploy, bring that existing infrastructure in. So we're going to shift gears here now, and I'm going to shift over to the vSphere side of the house, and we'll talk a little bit about what's new with VMware Cloud. With vSphere 9.0. Okay, so the first thing that we'll be bringing up here is this. With VCF 9, we use vSphere Lifecycle Manager images, or VLCM images. And many of you are probably familiar with the old VLCM baselines, or what we call the VUM. And we've supported both up until VCF 9. And so with VCF 9 and vSphere 9, when you deploy 9, you have to make that conversion because we're all in on the images. So, and along with having these images basically provide that desired state for our cluster, and we basically can say, hey, here's our image. We want all the hosts in this cluster to match this image, and it will basically do its best to make sure that that happens. And if there's any drift or anything falls out of compliance, we can then remediate it. But one of the challenges we've had with this architecture is that you were limited to one image per cluster. And sometimes I might want to mix a couple different server models or servers from different vendors into a cluster, whether that's a transitionary thing, as part of a hardware refresh, or maybe it's just I need some temporary capacity. But that was always a challenge. But with vSphere 9, we now have the ability to have up to 4 images assigned to a cluster, and these can all have separate hardware support managers. And so basically it makes it easier to have these hybrid environments where we were mixing different types of hardware into a vSphere cluster. Now, of course, we would never recommend this for a steady state. There's a lot of benefit to having all your hardware nodes the same, but there are these use cases, again, the hardware refresh or just need temporary capacity, where you might want to bring in different types of hardware and put them in the same cluster. And with the VLCM images and this added support for up to 4 images per cluster, we can now support that. So going on to the next feature, we introduced this previously as part of our 8.0 memory tiering. It was a limited availability, but now it's a fully available with vSphere 9. So this is basically just a capability where we can take advantage of the latest hardware capabilities, primarily around NVMe, and we have intelligence built into vSphere to allow us to basically be more efficient with how we stage memory and manage memory, and we can leverage the NVMe as a type of memory. And essentially what this does is it helps us to give the servers more memory capacity, and it's going to help us to be able to drive up better consolidation on those servers and help drive up better CPU utilization. So instead of having to hit a bottleneck early on because I'm out of memory, while I still have plenty of storage and CPU, now we can be more efficient with our memory usage, and we can basically increase those densities and be able to drive up higher utilization so that we can not only improve our memory utilization, but we can drive up CPU and storage utilization in those clusters as well. Private AI, everything AI is very popular, and there's a lot of people interested in it. And of course, when we talk about AI, we have to talk about GPUs. And with vSphere, of course, we have support for GPUs, and we have support for creating GPU profiles, or what we call vGPU profiles. This is all done from the vSphere client. You can configure these profiles. They give us visibility. So if you have servers that have GPUs, you have visibility into where those GPUs are. You can create these profiles to allow you to basically identify and set policy around them. And so you can go in and you can kind of view and see and manage those GPUs all from the vSphere client. So as you're bringing in those AI workloads and as you're introducing GPUs into your environment, you know, of course, GPUs are very expensive and something that we want to make sure we use very wisely and effectively. So with vSphere 9, we have the ability to help you do that through the vGPU profiles and the support for GPUs in general through the vSphere client. In addition to the improved visibility and the improved support for GPUs, we've also made several improvements around making easy to migrate workloads that are using GPUs. So basically using vMotion for these GPU-enabled VMs. So suffice it to say, a lot of times when you have these GPUs, they're large, they have a big footprint, a lot of memory, and migrating VMs with GPUs presented some challenges. So we've done some work to help make it easy to basically migrate VMs that are using the GPUs and to be able to do this very quickly and very efficiently. And this is just kind of, and let me see, what's this? Okay, so yeah, so and along with the what we've talked about so far, we've also had the ability to basically set some reservations for these workloads with GPUs. So in this slide here, you'll see we have an example where we have some ESXi hosts with GPUs, and we see we have VMs deployed on those 3 hosts, and now we have a new workload coming in, but there's no room for that. You can get in these situations where there's no capacity, but with these reservations, we can basically identify, hey, you know, while we don't have capacity initially, if we do vMotion and move some things around, we can make room and set a reservation, and so that we can ensure that these workloads, these GPU-based workloads, will always be able to be powered on, and we can be smarter under the covers with how we allocate allocate and assign GPU-based workloads to make sure we're getting the most efficiency out of those GPU resources. And of course, live patch is another new feature. This is something that we've had, we introduced again with 8.0, but it's something we'll start to see a lot more use of with vSphere 9. And essentially what this is a new way to basically apply those ESX patches. The first thing you need to remember is that as patches are released, they may or may not be a live patch enabled. So you need to pay attention to if the patch is live patch enabled or not. If it is live patch enabled, you will be able to apply it to the host. And the key here is you can do it without putting the host into maintenance mode without evacuating VMs. So support for live patch is there in vSphere 9, and you can expect to see this become available as we start to release patches for vSphere 9, where you'll be able to take advantage of this. And essentially, you'll be able to patch your ESX hosts without having to put them in maintenance mode, without having to do reboots, without having to migrate VMs. So a very nice feature. And then of course, we have a new virtual hardware version as well. And so I always like to think of each new virtual hardware version as kind of being bigger, better, faster. And here you'll see we have a number of improvements and a lot of security improvements as well. So be aware of the new virtual hardware version. And so with that, I'm going to go ahead and hand it off to Pete, who will talk to us about some of the vSAN improvements.
All right, thank you very much, Kyle. And yeah, it looks like we have a lot of great questions there in the Q&A that that many of the watchers have been asking. So keep those questions coming. For each portion of the presentation, we'll be answering those respective questions as we can. So there's a lot of new interesting features with vSAN for VCF 9, and we only have a time to really cover a limited set of them, but I chose some of the most compelling features that we have that have been introduced here. And I think when we think about compelling features, the first thing we want to cover is the introduction of global deduplication for vSAN in VCF 9. Now, this is specific to vSAN ESA. We had deduplication capabilities within the original storage architecture, but since the debut of vSAN ESA in 2022, that's been the one feature that has been lacking. But we really wanted to take a unique approach at making it bigger and better than ever, and that's really what we've done. So some of the key characteristics with the introduction of global deduplication in vSAN for VCF 9 is the fact that it is a cluster-wide feature, meaning that we have a deduplication domain that is the entire size of the vSAN cluster. Now, in the past, or the implementation of deduplication within the original storage architecture, that was limited to just a discrete disk group. When we increase the size of the deduplication domain, that means that we're going to be able to increase the likelihood that we find duplicate blocks. That's going to increase the space efficiency and, of course, drive down the cost of storage, which is really the primary goal of introducing this kind of a space efficiency feature. Now, the other characteristic that we wanted to make sure that from a design standpoint that we were doing this the right way is that we wanted to make sure that this was a process that was running in the background and not interfering with any potential performance of your really mission critical VM workloads. So this is a sort of asynchronous process. This is going to be running in the background, and it's going to automatically be able to detect when there are more free resources to be used for this process versus fewer resources to be used. So throughout the course of a business day, for example, it may be working on these activities less because those are being consumed by the guest VMs, whereas during off hours, then it's going to automatically throttle up and take advantage of those free CPU cycles for this processing. The great news about this for you is that there's no tweaking and tuning and adjusting and monitoring that you need to do. You're letting the system provide that sort of real-time monitoring and tuning for this sort of matter. Now, of course, this feature is fully capable and compatible with our existing services that we have with vSAN, things like data compression, snapshots, as well as erasure coding. One of the things, though, to note is that initially in the debut of global deduplication, this is going to be introduced as a patch within VCF 9, officially known, it will be patch 01. And we're also introducing it under limited availability. This means that if you're interested in deduplication, you'll want to reach out to your sales rep and let them know. And we can just simply verify that you have configuration and hardware settings that we are focused on making sure that this is really an ideal arrangement for global deduplication. But look for that to roll out to a much broader audience sometime in the future. Now, one of the things that you may be thinking is like, well, my existing storage array has a deduplication. So why is this any different or any better? It's a great question. When we think about deduplication techniques that are used in a traditional three-tier architectures using storage arrays, the domain of deduplication is historically the storage array itself. So the head unit and then any shelves that have the storage devices that are attached to it. So that means that when you scale out and add additional storage arrays, you're splitting that deduplication domain in half or thirds or quarters or however much as you grow and as you add additional storage arrays. Well, with a global deduplication within vSAN ESA, it's really quite different. As you scale and add additional hosts within a vSAN cluster, it automatically increases the domain or the boundary in which we can look for duplicate blocks. So that means that it becomes much more efficient as the size of the cluster actually grows. And so this is really counter to some of the characteristics and the capabilities that a traditional storage array has when it comes to deduplication. So we're really excited about this feature, and we look forward to really being able to introduce even more with it. Now, next up, we've introduced a new capability as it relates to vSAN storage clusters. Now, vSAN storage clusters is our way of providing centralized shared storage for your vSphere clusters, much like a storage array, but with the advantages of much more flexibility, better performance, scalability, and so forth. This new feature is called network traffic separation. And what this does is this allows us to take advantage of more than one VM kernel port on those hosts that make up the vSAN storage cluster, so that one VM kernel port can be used for back-end vSAN traffic, things that make the data resilient and rebalance the data and repair the data and so forth. We can split that from a VM kernel port that is responsible for sending those IOs to and from the vSphere host that mount the data store. So what this really does is that it's going to be able to improve the effective performance that the vSAN storage cluster can offer. But in my mind, that's not even the highlight of this. It allows for much more flexibility within the data center. Meaning, so for example, let's say we had a vSAN storage cluster that resided in a single rack within your data center. Using network traffic separation, we can make sure that that back-end vSAN traffic that is just responsible for that east-west traffic for the purposes of repairs and rebalancing and so forth, stays within the top of rack switches, or even a separate pair of switches that aren't even connected to the backbone. Meanwhile, those other uplinks could be responsible for sending that traffic out to the other vSphere hosts that live in their other respective racks. So a lot of flexibility with this new capability, and we're really excited about it. We've also made some nice new improvements within vSAN file services, improving the effective scalability. And by that, I mean the number of file shares that are supported for a single vSAN cluster running vSAN file services has been increased from 250 shares up to 500 shares now. So this is especially important for many of our customers who are focused on cloud native applications that use persistent volumes. Oftentimes what we see is there's a strong demand with the, sort of the scalability and the instantiation of additional cloud native workloads. You would need persistent volumes available for sort of storing that data. And that's really where this sort of need has really come from. So this should offer up a lot of flexibility, and even for those customers that were nearing the previous limit, this offers much more wiggle room now as well. Now, perhaps equally important to being able to store data is the ability to protect the data. And with vSAN for VCF 9, we've introduced some enhancements as it relates to vSAN data protection by being able to protect those VMs beyond the vSAN cluster itself. So in vSAN 8 Update 3, as a part of VCF 5.2, we introduced vSAN data protection. This was the ability for us to be able to protect the VMs using vSAN ESA snapshots, maybe in the way that you always envisioned it. You could set these schedules and retention periods for various VMs that you have in your environment, and it's automatically going to take care of the protection of those VMs without any impact on the performance. Well, in vSAN for VCF 9, we've extended this ability so that now you can protect those VMs remotely to another vSAN cluster. Now, this does require the VMware Live Recovery add-on license. So that is separate from the VCF license. But what that does is not only does that provide that replication capability, but it also provides the orchestration and the failback capabilities as a part of VMware Live Recovery, or VMware Live Site Recovery specifically. You may know that previously as Site Recovery Manager. So this offers really a comprehensive way in which you can provide the protection of your VMs, as well as the orchestration and failover and failback of those VMs, all natively to vSAN using the very same interface that you're already familiar with. Now, many of our customers use stretch clusters in a variety of different circumstances, and it shows its usefulness under a wide variety of scenarios. We've made some nice new improvements within vSAN for VCF 9 as it relates to stretch clusters. First off is the support of vSAN storage clusters in a stretch cluster arrangement, where you have a vSphere cluster that is also stretched as well. In the past, vSAN storage clusters did support the ability to be stretched across 2 geographic sites. However, a vSphere cluster never had the intelligence or understanding or the awareness of those geographic sites, known as fault domains. Well, we've introduced that capability now. So what this really does for you is that it offers a way for you to create what can be thought of as a metro storage cluster, but in a much more effective and easier way than traditionally found with storage arrays, where you would be building out a proper metro storage cluster. Those were historically very difficult to implement, as well as manage and grow and scale and so forth. Now, next up, we've introduced a new site-wide maintenance mode feature for vSAN stretch clusters. This is going to give you the ability to take one of your sites and enter all of the hosts into maintenance mode in a very orchestrated and guided manner. This is all built right within the UI. It's a single button, and it's going to take care of the rest for you. Historically, you needed to walk through a series of steps and processes in order to make that happen. And it wasn't difficult, but just like anything that you have a long list of steps with, it's a little bit prone to any sort of user error. So this sort of guided approach is going to make it much, much easier and has been a frequently requested capability by many of our customers. Now, related to that is the ability to recover from a failure condition under that very specific site-wide maintenance mode. And this is what's referred to as a manual site takeover. So imagine if you have a stretch cluster that you have one site under a site-wide maintenance mode, and for some reason there is some other double failure that occurs at the other data site and at the site that the witness host appliance lives. And let's say, for example, that there's no chance of recovery. Well, in those particular cases, you will be able to use this manual site takeover, and it will sort of reconstruct or reconfigure the objects on that one remaining site to treat it as a proper cluster so that then you can spin up your workloads and make everything available again. That step in the past, historically, you needed to engage with the global support team. And we wanted to make this a little bit more self-service. So that should really ease some of these challenges under, very high stress conditions where you were working under a maintenance mode event, and then you have subsequent failures for one reason or another. So there you have it. It's really vSAN, is storage that when you think about, for many of you, you have trusted the hypervisor to sort of manage your workloads from a compute memory perspective. So it really makes sense. Why not use it for your storage as well? And since it's a part of the hypervisor, it's a part of your licensing, even within VCF, that really makes it a compelling instrument for you to be able to make a much more efficient data center. And then because we own the entire stack and we have this full awareness from a VM standpoint, you have much more flexibility in being able to protect and manipulate these workloads as needed. And I think the example there of vSAN to vSAN replication is a great example of that. So that concludes my portion of the presentation. So I'm going to hand it over to Dimitri now.
Thank you. That was a lot of questions. Here we go. Let me share my screen. So now we'll talk about, here we go. I hope you can, oops, not yet. You can see my screen. Where is my screen? Where is my presentation? Beautiful. Here we go. Sorry for that. So let's talk now about networking. The networking in VCF 9 has its own large load of enhancements, but because as a lot of us already said, this VM Live section is only 1 hour, and I have only 15 minutes to talk about networking, I decided to highlight one specific enhancement, virtual private clouds, VPC, and specifically vCenter VPC. And I'll have even a large demo in the middle of that presentation to clarify everything. Now, of course, to give you a complete picture, I'll have a very brief slide at the end highlighting very briefly again the overall networking enhancements in VCF 9. Okay, so anyway, here we go. So virtual private clouds, VPC. So first, what is it? That the same thing you have in public clouds. So that's a network bubble where cloud tenants can create for their applications. And they can create one or many networks within their bubble and then plug their applications in them. And then they can also control the communication allowed or block the communication they want and they don't want in their bubble. And so at the end, you have a bunch of network bubbles, VPC, And for each of your applications divisions, you can share a single bubble or VPC, or have a dedicated VPC for each application, each division. And by default, VPC can communicate with each other for security reasons. But of course, communication can be allowed. Now, you can, as you can see here, you can configure your VPC and the networks in your VPC through a UI, even the vCenter UI, or you can also orchestrate that through automation, such as vCenter Power CLI or VCF Automation, or any orchestration tool you like, such as, I don't know, Terraform. And so at the end, you have a bunch of network bubbles, VPC, for each of your applications, divisions, and by default, VPC can communicate with each other for security reason isolation, as I said, but communication can be allowed. Okay, so now how does it work? So let's say you have a VPC with a couple of subnets, web and app. And since we're talking about VCF, so those are inside hypervisors ESX, and those ESX are connected to a couple of networks, vMotion, vSAN, and management not represented here, and one I'll call vNetworking, which is your NSX step overlay network. So within a VPC, you have automatically a VPC gateway, which is a distributed router. So inside each ESX, that's it for visual simplicity. I'm showing here only the VPC gateway inside ESXi1. And when a VM needs to reach its default gateway, it always does it locally. And then if it needs to talk to another VM, which is physically in another ESX, then that traffic is encapsulated through NSX step tunnel. So the physical fabric does not see anything about those VPC networks. So we could see that all traffic within a VPC is completely decoupled from the physical fabric and represented simply like this. So we could see that all traffic within a VPC, yeah. And now, why did we create VPC? So if we take, if we go back to history, like 20 years, let's say, yeah, almost 20 years ago. So when the vCenter admin needed to create an application, he was fully autonomous to create the compute, the storage, but then he had to open a ticket to the network admin to create a subnet, a VLAN, a default gateway, maybe some NAT, and at the end of that ticket, the vSphere admin would create a DVPG in vSphere, matching the VLAN of the physical network, and then could start working, deploying its application. Then we came like 10 years ago with a new model within VMware, the NSX model, where you have network virtualization through the component NSX. And now when the vCenter admin is also the NSX enterprise admin, the NSX admin, then the vCenter admin was fully autonomous. He could create deploy its application, compute, storage, and network in a fully autonomous way without asking anything from the physical fabric or the network team managing the physical fabric. That said, to be fair, the vCenter admin in that case required some good network expertise to understand logical routers, BGP for advertisement of subnets, and so on and so forth. So in many deployments, we end up with vCenter admin not in charge of the NSX component. And so back to opening a ticket to deploy or to get the network needed for the new applications the vCenter admin has to deploy. That said, the network admin in charge of the NSX component can do now with the NSX model all the network in the virtual space, which brings great benefits versus the vSphere model on the left, because now all the networks are available anywhere, and that simplifies a lot the move of applications across within a data center or across data centers, help tremendously also on DR and plenty of other things. But back to a ticket again. So what we're introducing in 9.0 is the VPC model, where now the vCenter admin directly from the vCenter UI in a very simplified way, and I'll show you that in the recorded demo in a minute, can deploy on his own the network needed for his application without any requirement to open ticket and without any requirement to be an network or an NSX expert. And this still with the physical network admin fully responsible of the IP addressing of the data center, because he doesn't want to lose this ownership, and we fully understand that. So the vCenter admin with VPC can consume networks that were provided by the network admin, but you'll see that directly in the recorded demo that will make all sense. So here we go.
Here is my freshly deployed VCF workload domain and its vCenter. Let's use vCenter now to deploy two new
I'm wondering if I'm sharing, if you have the sound.
with
I guess
dedicated
not. So let me start over. Let me share again, but this time with the sound. Oh, I was sharing the sound. Oh, my bad. So here we go. Let's start over.
Here is my freshly deployed VCF workload domain and its vCenter. Let's use vCenter now to deploy two new finance and marketing two-tier applications with dedicated isolated networks for each. The vCenter admin already deployed the compute and storage of that application with the finance and marketing web tier and DB tier VMs. And now the vCenter needs to create the network for those two-tier applications. But this time the vCenter admin won't open tickets to ask the network team to create the new VLAN, default gateway, DHCP servers for each finance and marketing application. The vCenter admin will create those directly from vCenter on his own. So for that, he goes to vCenter networking and virtual private clouds. And you can see that at the VCF workload domain deployment, the network connectivity has been completed. And it has been completed with an external IP block 31.31.00/16. So any new VPC public network will come from that block. By the way, that IP block was provided at the deployment of the VCF workload domain by the company network administrator, who obviously owns all IP addressing in the company. So let's go back to VPC and create that VPC finance. I'm calling it VPC finance, and let's provide a private IP CIDR 10.151.0.0/16. The company network admin is not involved in the VPC private addressing, since those private IPs are limited inside the VPC. They'll never be used or be seen by the physical data center and the outside world. So that's it. The vCenter admin creates a VPC, a virtual network bubble, for his new application finance. Now he can create the two subnets, public and private, needed for that application finance. So let's create the first subnet, FinWeb, and let's make it public because I want the external world to be able to reach it. And let's make it small since I have only one IP, so 16 is more than enough. And let's use DHCP for my VMs. And now let's create the second subnet, FinDB, and let's make it private because I do not want the external world to reach it. Only the web tier can be reachable by the outside world. Now let's plug my finance VMs to those VPC subnets. There are two ways to do that. Directly from VPC, and that's what I'm doing for my web tier VM. or editing the VM. And you can see here for my DB tier VM, I have the VPC networks in their own tab to help the vCenter admin to select the right network. Let's power on now the VMs. And waiting for the application to boot up, let's look at another cool thing available in vCenter VPC. Here you have a nice graphic, a nice representation of the VPC networks with the different subnets and the VMs attached to them. And directly from here, you can also see the VM IP address. So here is my web tier IP address, and I can access the new finance application that the vCenter admin fully deployed, compute, storage, and network from vCenter UI. And here we go. The external users have access to the web tier, and the web tier has access to the DB tier. And you can see the external users do not have access to the DB tier. Now, if you want to provide external users access to the DB tier, then the vCenter admin on his own can create a one-to-one NAT, also called external IP, for that DB VM on a private network. Here we go. So now external people have access to the private DB VM through its external IP public, and that access can be via ping, or that access can be via any other protocol such as SSH. Okay, so the vCenter admin fully deployed the finance application, compute, storage, and network, and he needs to do now the new marketing application. So the vCenter admin could follow the exact same steps with 50, 60, click, click, click. But this time he doesn't want to do it via UI. He wants to do it in a faster way through automation. And for that, he will use PowerShell, a PowerShell script that will do all of that. So here is the script. And let me launch it. In a couple of seconds, the whole marketing application is deployed, compute, storage, and network by the vCenter admin through a single click or a single script. From the UI, the vCenter admin can now look at the new VPC marketing topology, or can look at all the VPC topologies. And from there, you can find a specific VM IP, such as the marketing web frontend VM. And so now with this information, external users can access the marketing app. Here we go. And now, if people want to access the DB tier app, which is in a private subnet, that's through its external IP, which can be easily found also in the vCenter VPC topology. Here we go, 313103, and I can access it now. This wraps up the demo of vCenter VPC with full deployment of applications by the vCenter admin. Thanks for your time and see you soon.
Okay, so if I wrap up on this great announcement in VCF 9, the goal of VCF is really to enable public cloud experience in your private cloud, in your private data centers. And VPC is a core component or core building block for that capability. And VPC rely behind the scene on NSX, but as you have seen in the demo, there is not even a need, there is zero need to go on the NSX component itself. You can do that directly from vCenter. If you want to do it from NSX, of course, your API you can, but you don't have to. And VPCs are not only consumed by vCenter, but they are also consumed by other VCF components, such as VCF automation. There is monitoring reporting through VCF operation. It's consumed by VMware Kubernetes services, HEX. So it's really a core component in VCF. Now, as I said in the introduction, there is much more in VCF 9.0 on the networking front. You have the exhaustive list here. I won't have time to go through all of that, but as you can see, there are enhancements under advanced networking, even for those who know NSX, the ability to run in VCF 9.0 networking services without any NSX edge nodes, reducing the footprint. Actually, that demo was done without any edge node, but also enhancements under management operation, under scale, high availability, and also plenty in the integration within the whole VCF solution. Okay, thanks for your time. I don't want to take more of that, only 5 minutes left. Let's go to the next presenter, Kyle, to wrap this, to talk about one more topic and wrap it up.
All right, thank you, Dimitri, and thank you, Pete, for presenting. So we are going to wrap up with this last section. There was a couple of questions about this in the Q&A, but with regards to what we're calling fleet management. And so with VCF 9, VCF Operations is now a required component, and it will be deployed as part of every Cloud Foundation environment. And in addition to having VCF Operations, we've made a number of enhancements, particularly around bringing additional capabilities to the VCF operations. And several of these capabilities were formerly available on the SDDC Manager, and they've now been moved into the operations under what we call fleet management. And this is going to include, I think the best way to show this would be to kind of just do a demo. So let me come over here and just show you. This is VCF Operations 9, and you'll see under the fleet management, we have identity and access, certificate management, password management, tags, configuration drift, lifecycle, and task. And so essentially, because of time constraints, I'm just gonna go through these really quick, but identity and access management, this is essentially how we can set up a common identity source across the full VCF instance. So I can basically go in and set up what we call VCF SSO. So you see I come in here and I can set up a single sign-on instance for my environment. Here you can see I come in and set up the identity source. I can use the OIDC as well as the SAML protocols. I can also use Active Directory or Open LDAP. But once that's set up, I go in and register my components to use this, and then I can go in and now have a single method for authentication. So I can basically jump between my vCenters, my NSX, my VCF ops without having to constantly log in. And here you'll see, like, if I've added these components, if I want to add another component, it's very easy to go in and add it. You just simply go in and point the component to it. There is some additional steps required up here in this blue box to basically go in and to set up some of the role-based access controls. But once that's set up, we do have this single sign-on across the VCF stack. And so that is what we call VCF SSO. I'll just kind of throw this out real quick that with VCF 9, you'll read that vCenter Enhanced Link Mode is being deprecated. And so a lot of people really like that single pane of glass and that ability to have all their vCenters linked together and be able to log into the vSphere client and see all their vCenters in one view. That view still exists, and to get that view, what you do is you go into VCF Operations and you enable VCF SSO first, and then you can go in and do what's called vCenter linking. So this is kind of a new capability that replaces some of those older capabilities that you've been using. Along with the single sign-on, we also have centralized password management. So this is, again, something that used to be in the SDDC Manager. It's pretty straightforward. You basically go in, you have your components here, and you can go in, you can update the password and manage your passwords here, all from VCF Operations. And we have for the manager components as well as for the vSphere components. So here we're seeing the manager components, the operations, the automation. If I click on VCF instances, we would see the vCenter, the NSX, things like that. You'll notice that in addition to update, we have remediate. So if for some reason a password gets changed outside of VCF and you need to now notify VCF, hey, this password was changed, this is what it was changed to, that's what the remediate is. That's the difference between the update and remediate. Along with the centralized passwords, we have centralized certificate management. So here you'll see we can go in and do centralized certificate management across the stack, and we now have support for ESX host. And just as in the past versions of VCF, we can go in and configure a certificate authority, Microsoft or OpenSSL. Just do that real quick in this example. And then once you set these up, you'll see I can come in here and I can go in and generate a certificate signing request. And then I can provide those details. And then once that's done, I can either send that off to have it signed by an outside authority, or I can go in here and just use my configured certificate authority and go ahead and replace the certificate. And you'll see it will go through and it will update the certificate. So we've updated this ESXi host certificate to a new certificate. And you'll see that we also have the ability to set up automatic renewal as well. So if you want to basically have that happen as well. And so, yeah, so we've talked about the identity management, certificates, and passwords. There was a question about configuration drift, and hey, as we go to vSphere Lifecycle Manager, and as I have all these clusters, is there a way that I can go in and identify if the configuration between my vCenter servers or the different configuration between my vSphere clusters has drifted? Has anybody gone in and changed any of the configuration? That is what configuration drift allows us to do, is go in and basically set policy and say, hey, I want all my vCenters to apply to this policy, or I want all my clusters to apply to this policy, and then it will basically go in and monitor, and if it detects any changes, it will notify you of those drifts. And then the last piece here is the lifecycle. So lifecycle is where we do patching and upgrading. And so what we've done here under the VCF operations is we've taken the formerly known as the vRealize Suite Lifecycle Manager, or the ARIA LCM, and we've combine those capabilities with the SDDC Manager lifecycle manager capabilities and place them all in a single place here. So if I come into lifecycle, you can see this is where I can do patch and management across the stack. So here, like if I go into my VCF instance, this is where I can go in, set up my depots, and manage the binaries and patches and apply them. And I can do the same thing for my ARIA operations and automation components as well. And so with that, I think we're at the top of the hour, and that brings us to the end of our presentation. So this is part one. There will be a part two to follow on July 8th. So on that part two, we will be covering a lot more about VCF operations. We'll be getting into the vSphere Kubernetes service, VCF automation, and we'll also be hearing about some of the security and data security and private cloud security capabilities as well. And so with that, I think we'll go ahead and wrap it up, and I'll hand it off, and we'll close out the session.
Awesome. Thank you so much, presenters, and thank you, VMUG members, for being here. And hope you have a good rest of your day, and we will send this recording out to everybody. So thanks. Have a good one.
All right. Thank you.
Thank you.